That's good. My last class, the first time I clicked on start recording, there was an error, but I was able to try it again and it worked. Anybody have any questions before I get started? I do want to remind you that test 3 is on Tuesday, 11/24. Earlier this morning, I sent you all a video link. Last night, I had a conference for my online Anytime students, and I went over the 7 written work required topics, and I sent you a link to that video. So if you want to know what those 7 written work required problems are, I need to send you out an email about specifically the list of those topics, but I haven't yet. I will. But if you want to know what those 7 written work topics are and hear me present them all at the same time, that video link I sent to y'all this morning in Canvas is something to take a look at whenever it's convenient for you. You might want to look at it today just to see what the written work topics are for test 3. But that's all in one place. And there's a video there with me talking you through it. So I think that would hopefully is a helpful resource for you. And I'm trying to give you as many resources as I can because we all have different learning styles. So does anybody have a question or a comment? So if you need help at any time, let me know. I'm here for you. I really am trying to do my best to see that you all succeed and have been for the duration of the semester. There are certain things out of my control, though. Like I have to make sure I comply with the Arkansas Department of Higher Ed and our division and our department. So I can't, as a faculty member, just completely control everything that I do. So let's go ahead and get started. We are going to look at this particular objective today on, I'll go down to my desktop and let's take a look at, I believe this is called important theorems. So let's take a look at this objective. So you have an objective that's due tonight, I believe. Correct? I think that you've got one that's due tonight. Let's take a look at Alex real quick. I'm gonna get that, need to get that going. Let's go to Alex. And see when our objective is due. And the best place to go is these reports, this Alex Pike. Okay. So intro to polynomial functions, the current objective is due 11/12. That is tonight. So the objective that we're looking at today is important theorems. And then you can see the test 3 review objective. The progress is high here at 68% because this test 3 review objective in there are topics that you've already seen. So if you've already gotten credit for those topics, this review objective will automatically give you credit for them as well because you've seen them before and you got credit for them before. So we're going to look at these particular topics today. And I wanted to show you that. And I'm just going to go on into Alex here and hope that I'm going to leave it there and hope that I don't have to redo everything because I want to go into the Alex software to show you something in a bit. Okay, let's go back down to the, do you have a question? Anybody have a question? So I did send you that video today, so that video link today, so you should be good with that, with the 7 written work topics. I want to make sure I'm not forgetting to tell you anything. So let's get started with these important theorems. So we are at the point in the course where the topics are getting more challenging. That's why you're seeing fewer of them in objectives now. And that probably will happen for the duration of the course. So let's look at writing a quadratic function given its zeros. When you have a quadratic function and you factor it and set it equal to 0 and solve for x, you're actually finding the zeros, Z-E-R-Os. Here, we're going to do it in reverse. We are going to be given the zeros, write a quadratic function f whose zeros are -3 and 5, and we want to write the original function. We're going backwards here. So we're going to start off with something fairly simple, and then we're going to work our way up. And the last topic we are going to do today will be one of the written work required topics on test 3. This one, write a quadratic function whose zeros are -3 and 5. So a quadratic function, just to remind you, is a function in this form. It's a function like this. It's f of x equals x squared. Oh, let me back up. I forgot you could have a coefficient in front. It's ax squared. Ax squared is usually how it's written. Ax squared and then x squared plus bx plus c. So that's a quadratic function. Now, what's important about a quadratic function is the highest power that we see is this 2. That means we have 2 solutions. Said a different way, solutions mean exactly the same, has the word 0, Z-E-R-O. A solution is a 0. A 0 is a solution. A 0 is an x-intercept. An x-intercept is a 0. So it's important to understand that the word 0 spelled out, x-intercept, solution, an x-coordinate that makes the y-coordinate 0, those are all synonymous. They're all synonymous with the word 0, Z-E-R-O. So that's important to note. What we are given here are 2 different zeros. So because we're only given 2 zeros, we know we are finding a quadratic, because this tells us how many zeros we have to account for. The highest power on any polynomial, for any polynomial function, tells us how many zeros we have to account for. We have to account for 2 zeros for this particular problem. And so we happen to be given those in this problem, but we will not always be given them. We will need to find them. And more often than not, we will need to find them. So how do we find them? It turns out that zeros are related to factors. How are they related? They are related by the factor theorem. The factor theorem says that x minus each 0 is a factor of our polynomial. In this case, we have a quadratic polynomial. So how we want to find our polynomial, our quadratic function, is we are going to take advantage of this factor theorem. So here's a 0, x minus that 0 is a factor. So our function that we are trying to find is f of x. So I wrote down f of x equals, here's a 0, x minus that 0 right here is a factor. Factors are multiplied. So there's an understood multiplication sign here. And then x minus this other 0, 5, is a factor. X minus 5. Let's clean up this factor. Minus a minus is a plus, so we have x plus 3 times x minus 5. Now, Alex didn't want me to multiply this out. It just wanted me to write in factored form. But we could multiply this out and we would get a quadratic. We would have x times x, which is x squared. There's our x squared term. And then we would have minus this, the outer 2, x times negative 5 is negative 5x, plus the inner 2, which is plus 3x. So minus 5x plus 3x is negative 2x. And then the last 2 minus 15. So if you needed to actually multiply it out, you could. Alex said to leave it in factored form, so I just wrote down x plus 3 times x minus 5 for the answer. Any questions on this particular topic? We are going to do another question in the same topic. So feel free to ask questions at any time. It's likely helpful to other students as well as it's helpful for me. Any insights that I can get from my classes on where I can help them is very helpful to me as an instructor. What I can do to help you is so important to know, and that's a good way to find out by the questions you ask. And I don't think any question's too small. I really don't, because I don't want the smallest little algebra technique or tip or whatever to hold any of you back. So let's look at another question in the same topic. Anybody have any questions at all? Even if you say something wrong, I don't keep a tally of who said something wrong. I really don't. My brain does not work like that. So anybody have a question? Anytime, stop me. You can unmute your mic and ask a question. That's fine. I don't think we're going to have a problem with that. So this question, same topic, write a quadratic function. Now, remember, we have to have an x squared term in our quadratic function. Write a quadratic function h, whose only 0 is negative 11. So we're only given 1 0. And if we write down the factor, remember, what's the relationship between a zero and a factor? X minus that 0 is a factor of our polynomial. So if we do x minus 0 here, and let's do it up here. If I write down x minus, oh, that's not going to let me do that. Let's see if I can trick it a little bit by switching to some other color or something. So x minus this 0 here. Let's write down a factor, x minus our 0, negative 11. And if you thought that was the answer, what you can do is take x minus, it may or may not be the answer. In this case, it is definitely not. But right here, this x minus a minus is x plus 11. If you just put that in over here, just x plus 11, you would get the answer wrong. This is in y equals mx plus b form. So there's an understood coefficient of 1 there. So the m is 1 and the b is 11. And we don't have any other factors listed. Since this is in y equals mx plus b form, the graph is a line, which means the function is linear, not quadratic. So we have to figure out what we need to do next. You're not going to get the right answer if you type in x plus 11. So we're talking about a quadratic function, which means we really need to have a squared term in it. We need to have, let me see which, we need to have this squared term here for a quadratic function, and we don't have that. So the only thing we can really do is assume that this 0 occurs more than once, and for a quadratic, that means that it occurs twice. So we don't just want to take x minus a negative 11 once, we want to use it twice, that factor. And if we do that, we get x minus a minus 11, which is x plus 11, here from this factor and this factor. And we could write that as x plus 11 squared because we have two of the factors x plus 11 multiplied together. And if you were to actually FOIL this, this is where you would get your x squared. X times x is x squared. So we have accounted for our x squared that we need. So the answer is x plus 11 raised to the second power. I believe Alex would also accept x plus 11 times x plus 11. Anybody have any questions on this first topic? This is a warm-up topic.
So when it asks to write a quadratic function, it doesn't want ax squared plus bx plus c.
It wants you to leave it in factored form. And I have this note here that suggests that that's what they wanted because I put this note in here. They just want you to write it in factored form.
Okay.
Good question. Any other questions? Comments? We're all in this together, so even advice. I mean, we're all in this together. Something, hey, have you thought of trying this? So we're going to go through a series of progressions here. Now we've gone from a quadratic is degree 2. The degree refers to the largest exponent. This degree here is the largest exponent. Let's use power. It's got less letters. Start here. Let's get it a little closer. So the degree refers to the largest power. So if you were looking for, if you want to find a polynomial, f of x of degree 5, that's going to mean that we need to account for 5 zeros and 5 factors. So that's what that degree, how that degree affects polynomials. That means that there's 5 zeros, zeros, and 5 factors. I will state that a 0 may be repeated like we saw in the last example. The last question we did, we saw a 0 of, let's just go back to refresh. We saw a 0 of negative 11 or twice. that zero repeated. That was a repeated zero. So this particular quadratic function has a zero of negative 11 of multiplicity 2, meaning that that zero appears twice. So this one, we want to find this polynomial. And we are going to leave it in factored form. So you don't have to multiply all this out. And going back to the question that was asked, I think that's why Alex doesn't require you to multiply it out, because they're giving you fifth degree polynomials. So let's do exactly what we did before. The factor theorem says that if you have a zero, we've got 5 of them, then x minus each one of those zeros is a factor of our polynomial. And there is that one-to-one correspondence between a zero and a factor. So let's start and go in order. So Alex is calling our polynomial f of x. So let's start with that. F of x equals, here's a 0. So we put in a 0 is an x coordinate. So we put 3 in here. So, well, actually, no. This is x minus this 0 spelled out. So these zeros are going in here. I mean, a 0 is an x coordinate. There's no question about that, but it's not how it works here. So we're going to put we've got 0 spelled out. So we're going to put it in each one of these in for here. Okay. So each one of these zeros is going to go in right here. And then we're going to do that for all the zeros. So we're going to have one factor for each one of these 5 zeros. So we're going to have 5 separate factors. 1, 2, 3, 4, 5. So our first factor, x minus this 0 of 3. That means we're going to write that as x minus 3. Our next factor, we are going to write it as x minus this 0. And that goes right here. So let's use this top row because of the 0. I want to write it out like this, x minus 0. And then x minus 7 is a factor. And x minus a negative 5 is a factor. And lastly, x minus 8 is a factor. And we are just going to clean up these factors. So x minus 3, copy it down. X minus 0 is just x. X minus 7, x minus a minus is a plus, x plus 5, and x minus 8. So this is the answer that Alex was looking for. What I've got encircled at the right here, that's what they were looking for. The truth is, you might be able to get away with this. I'm not sure. I didn't test that. You might be able to. Any questions on this topic? This interplay between zeros and factors is very important. We will see a problem at the I think it's the last problem we are going to do today, where you're going to be asked to factor a cubic. And that is a written work required topic on test 3. Now we've seen the concept of multiplicity already when we were talking about I believe negative 11. So let's do one of these topics where you could see, and this could be, let me see, this could be a given zeros, real zeros. This is the same topic, different question. So they could definitely give you a zero that has a multiplicity of something other than 1. So how do we handle that? Well, let's start out the same way. What does multiplicity mean? A multiplicity of 2. So we have a 0 of -6 of multiplicity 2. That means that 0 of -6 occurs twice. We have a polynomial of degree 5. If we only counted -6 once, what would happen? 3 plus -3. So we have, here's our first 0. That's 1 0. 2 zeros if we're only counting it once. 3 zeros, 4 zeros. We would only have 4 zeros. But we're told that this is a polynomial of degree 5. So we would be missing out on a 0. Where's our other 0? Well, that's where this multiplicity 2 comes in. That 2 means we have 2 of these zeros of -6. The 2 of our zeros are both -6. Each one of those 2 zeros is -6. So that's what that means. So we have our zeros. We want to leave our answer in factored form. So be sure you're on the lookout for that, or just, I think for me, I was able to put all of mine in factored form, and Alex marked me correct. So we've got our zeros. We want to find a polynomial, and the only way we can really do it with when we're just given the zeros is to find the factors. And the relationship between zeros and factors is this: x minus a 0, zero, is a factor. So let's do just what we did in the last problem. We'll call our polynomial f of x to be consistent with Alex, equals x minus the first 0, which is 3, in parentheses, because we're writing it down as a factor. Factors are multiplied. Then when x minus -6. So x minus -6 is like that. Now this multiplicity of 2 means we have it twice. So I wrote it down again. X minus 9 is another factor. X minus a -4 is our last factor. And just cleaning those up a bit. X minus 3. X minus a negative is a positive, so x plus 6 twice. X minus 9, x minus a -4, that's x plus 4. And I didn't check it, putting in x plus 6 twice as factors like this, but Alex may take it that way. They seem to be pretty good about taking answers different ways. So that's, you might try entering it like that, but I chose to combine these into these 2 factors in a sense and write it like this: x plus 6 squared. So I have 1 here and 1 here. This 2 means that there are 2 of the x plus 6's multiplied together, which we have right here. An exponent of 2 just tells us how many of this base x plus 6 in this case do we want multiplied together, and we want 2 of those. Any questions on this particular topic? So notice that a multiplicity, this had -6 is a 0 multiplicity 2. That 2 appears in the exponent here on the factor x plus 6. That we found that factor by taking x minus a -6. So that multiplicities are really exponents. Any questions? So why are we looking, where are we going with this? Where we're going with this is we want to look at polynomial functions, which we've looked at linear functions and quadratic functions. Do you have a question? Okay. We've already looked at linear functions and quadratic functions, but what we want to do now is look at cubic functions like this, but that have a power of 3, and quartic functions that have a power of 4, which we will look at on Tuesday of next week. We're going to look at some cubics today though, just to get us warmed up. So we have a special division process called synthetic division that is going to allow us to identify zeros, Z-E-R-Os, pretty quickly. And if we can find a 0, say we have a cubic, if we can find a 0 to get started, we already have, and we find 1, what we're going to do is then we can say x minus that 0 is a factor. Say we've got x minus 2 as a factor. Well, then what we're going to do is we are going to use a process that will then, which is actually on the screen now, which will then, when we go through that process, we will then find a quadratic quotient, and that we can factor easily either by using our factoring techniques or by using the quadratic formula. So that's really where we're going with all of this, to have the ability to factor cubics and quartics, 3rd degrees and 4th degree polynomials. Now I had mentioned earlier that I wanted to go into Alex here to look at something, and we did not get kicked out, so good. So let's go into Alex. I don't know how that happened. Enter student view. And it took me right back there. That's weird. I want to let me enter and again, I guess I may have to go out and go back in because somehow there's some kind of glitch or something. So let's go back out and I will start here. And see if that will work. And it won't. So let me get rid of that. And I guess I'll just click on the class and maybe that'll take us, let me go all the way out then and click on just the instructor. And let's select, I'll do 12.0, my earlier class because I know it worked there. And let's go to class tools. So we are going to talk about a division process that is useful. Now, we're going to talk about synthetic division. If you are really into long division and you understand that really well, you're welcome to use long division, but I won't be presenting long division. I will be presenting synthetic division. So I want to go right here, review. And let's see, I need to select where we're at. We've done a lot, there's no doubt. Important theorems. Let's see here. Use the given 0. So I think this one is the one I want to look at. And this is going to come up not only in this particular objective and probably in the next one as well. Let's look at an explanation. Now you will see on the explanation page, Alex is using long division. But they have a synthetic division option right over to the side here that is encircled in orange. So you can click on that, and there's where they're going to give you the directions of how they see it of using the synthetic division. It's very interesting what's going on here. And what happens with, normally there's another term over here when you use long division, but because there's a 0 remainder, that term isn't there. And what we can do is take this x minus 1, it's participating in division, and move it over here so it participates in multiplication. with this factor right here, and we are then able to factor our cubic at least down to a quadratic and a linear. And then we can use our quadratic formula to further factor the quadratic factor. That's what I want to say. So I just wanted to kind of show you that and just let you know that, hey, I don't want you to think, hey, why did you present synthetic division when Alex is only using long division? And really, they are also presenting the synthetic division. You just have to click on that option. So let's go back to our presentation here. So we are going to look at synthetic division. This particular question says use synthetic division to find the quotient and remainder when x cubed minus 11x plus 20 is divided by x plus 4. Specifically, complete the synthetic division table below. That's this table right here. And write your answer in the following form: quotient plus remainder over x plus 4. Now, Alex is going to have you write it right here, that what they're asking for there, write your answer in the form. We just have to fill out this box. You can see quotient plus remainder over x plus 4 right there. So we have a process that we want to learn here. It's quicker than long division because if you remember when we looked at long division, and I didn't point this out, so let me see if I can turn this off somehow. The big difference between synthetic division and long division is that in long division, you need to write all these x's down all the time. In synthetic division, however, we're not writing down any x's at all. So it's a time saver, really. So let's get started here. The first item that I want to talk about is why did Alex put a -4 here? Because you will need to, part of our learning is going to be learning how to put these numbers in right here. How you will need to decide which number to put in here. So we're just learning, so Alex put it in here for you. And where that comes from is this divisor right here. Now this 4 is being added to x. This 4 is next door to x. It's being added, or this 4 is being added or subtracted next door to x. We've seen this phenomena before, not in the context of what we're doing now, but when we were translating graphs, when we wanted to translate graphs horizontally. And we saw that worked opposite of what we thought. So when a number was next door to the x in that situation, we saw that it worked opposite of what we think. The opposite of what we think still applies here. So when you are adding a number or subtracting the number next door to the x, it works opposite of what you think in this setting as well. And so since this 4 is next door to what we think, we don't put in +4, we change the sign and put in -4. It works opposite of what we think too, or opposite of what you may think. So these numbers right here, where did Alex get these numbers? From the original function here. Now you notice that for synthetic division, the coefficient, then that is the number in front here, which is 1, goes right there. Synthetic division, we have to account for every single term, whether it's in our original polynomial or not, or whether it doesn't, if it's part of the polynomial, but it's not written in that there's a zero coefficient out front, we still need to account for it in synthetic division. We still need to put those zeros in. So our first term is x cubed, and its coefficient in front is understood to be a 1. That's why there's a 1 here. Now, if we take this 3 and decrease the power by 1, we'd get 3 minus 1, which is 2. We do not have an x squared term here, but there really is one in the synthetic division table. So the coefficient in front of x squared is considered to be 0 because 0 times x squared is 0. So we still want to put that 0 placeholder in our synthetic division table. So we've accounted for x squared. If we take that 2 and subtract 1, we get x to the first, which is just x, and that coefficient is minus 11. So that's why you see the minus 11 here. And lastly, we have a constant term, which is really 20 times x to the 0 power. Any non-zero number to the 0 power is 1, and 20 times 1 is still 20. So you want to put in that constant, which is 20. So let me show you how this works. So the first thing you want to do here is to just whatever this number is, you want to drop it straight down. So maybe I didn't write that big enough. I thought maybe I'd try to put it over here so you could see it. So you just want to drop that first number down. So let me just write it maybe like this. Drop that first number down. That's an O there. So you just drop this first number down. So in other words, this becomes a 1. Then what do? So each one of these boxes is going to involve using that negative 4. So what do? We take the negative 4, we write it down over here, and use it each time. What do we do with that negative 4 each time? We multiply that negative 4 each time. We want something to put in this box up here. So we multiply that negative 4 each time by what's at the bottom of the previous column. In this case, it's 1. So we take negative 4, multiply it by 1, and we get negative 4. And that's what goes right down here. I don't really have enough space to write that all down. And then you add straight down. You just add straight down. 0 plus negative 4. 0, I want you all to be able to see 0 plus this negative 4 we found up here. 0 plus that negative 4 is negative 4. So, and what we found down here would actually go in this box. This negative 4 would go in this box up here. It just goes in the first box. I just did it below so you could see what I was doing. So let's erase that so we can just look at what's at the bottom there. And I need to put this on to erase that. I don't want it to get it too cluttered up. So what we have now at the bottom here, when we add these two together, we have 0 plus negative 4, we have negative 4. So negative 4 is what goes in this box right here. This box right there. That's what goes there. Now, each time we need to put something in one of these boxes up here. we need to use -4 here. So that would be -4 times what's at the bottom. We want this box, so we want to use what's at the bottom of the previous column. So that would be -4 times this -4, which is 16. That's where this 16 came from. And if we add those two numbers straight down, -11 plus 16, that is 5. So 5 goes in this box. Goes in this box up here. So now we're going to take one more time and use this -4 times this 5. And we get -4 times 5, we get -20, this one. And when we add straight down, we get 20 plus -20, which is 0. And so we took this -4 times this 5, and just to remind you, -4 times 5 is -20, and that's what went right here. And then there's a -20 here, 20 plus -20, we just get 0 in this last box. So that's how this is done. So just remember, it's drop, and then you're going to do a multiply, and then that's going to go in this box, and then you're going to add straight down. Then you're going to do a multiply. You're going to take -4 times where the pencil is. So that'd be -4 times -4, which is +16. You're going to put that in this box, and then you're going to add straight down. -11 plus that 16 will give us +5. And then you're going to take -4 times 5 to get that -20 and add straight down to get 0. So it really is this drop, multiply. Every time you multiply, you're going to use this -4 in this example, or whatever number is there. And then you add straight down. You move over to the right, and or you move to where you need to move to, and then you add. So it's drop, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add until you're done. And we're going to do some more synthetic division. So I think you'll be pros by it by the time that we are done. Now, let's see what we need to answer in terms of this question. All we have done is has started to fill in this table. I haven't filled it in all the way. I've got all the answers are right here, actually, for the synthetic division tableau. So if you want to see what they are, we could, so you've got -4 here, and just to go over it, what are we doing? We drop this down. We take this -4, multiply it by this +1. What's in blue here? That -4 times 1 is this -4. So it goes right there. Then we add straight down. 0 plus -4 is -4. Now in orange, what do? We need to take this -4 this time times this -4 to get 16. We add straight down. -11 plus 16 gives us 5. -4 times that 5 is -20. Add straight down and get 0. So it is definitely that process of dropping the first number down to get started, then multiplying. Every time you multiply, you want to involve this number in multiplication, and then what's at the bottom of the previous column has the other factor in that multiplication. Any questions on this? And we need to talk about quotient and remainder. So we're going to come up with some numbers down here. Those numbers are extremely important. We usually take this last number, and I like to put a vertical bar here because I want to separate the remainder from the quotient here. These numbers participate in the quotient. This last number is the remainder. The remaining numbers are coefficients of the quotient. So what quotient are they? Let me write out that quotient for you, so you can see and get a visual of what that quotient looks like. So this quotient is really, when we take, I just thought of something else I wanted to point out. So just looking at this right here, what we're really doing is, in some sense, is taking x cubed and dividing it by x. So we have 3 x's in the numerator in some sense, and 1 x in the denominator. Well, if you take 1 x out of the numerator and the denominator, that 3 is going to become a 2. We're taking one of those x, we're dividing out one of the x's. So we're taking one of the x's out of here, we're left with just x squared in the denominator, and that x that we're taking away from the numerator will cancel this x. So we will just be left with x squared. So x cubed divided by x is x squared. So that's going to mean that we're just going to get a quadratic over here as part of the quotient. So what we have down here, these numbers are really coefficients of a quadratic factor, or perhaps not a factor, but of a quadratic expression, more precisely a quadratic expression. So they are coefficients of that quadratic expression, and if we start here after this vertical bar, this is the constant, this is the coefficient of the x term, this is the coefficient of the x squared term. So you can go backwards, constant x, x squared. Or if you think you really understand it, you can go forwards, x squared, x, and constant. But keep in mind, we're going to be working with quartics, which means occasionally we might have cubic down here instead of a quadratic expression. So if we write down our quotient, it would be like this. Oh, actually, I've got it up here. So our quotient is 1 times x squared, which is what Alex wanted in this box here, the quotient box. So it's 1 times x squared minus 4x, the x I wrote it in here, so you can see that, plus, or actually I have to go down here to see that, plus 5. We've got a positive 5, so it's plus 5, as opposed to minus 5. Plus the remainder goes in here. So our remainder being 0 is very interesting because we don't have anything over here now, and all we would have to do to factor or get well on our way cubic up here is to take this x plus 4 and move it to the other side, and then we'd have this factor times this factor of x plus 4 over here, and we would then be well on our way to factoring the given cubic. So that's where we're headed. Any questions on this? And I promise you I will do some more, so if you're not getting every little detail, hopefully by the end of class you will have every little detail. Let's go on. So this is just much cleaner here, so I think you will understand that will be helpful. This is another question in the same topic. Use synthetic division to find the quotient and remainder when negative 4x cubed plus 11x squared plus 8x minus 10 is divided by x minus 3. Specifically, complete the synthetic division table below and write your answer in the following form: quotient plus remainder over x minus 3, which is the divisor. So let's do this one. And just to see how they created this, we look at this number out here, comes from the divisor, x minus 3. 3 is being subtracted next door to the x. So when we want to do we're going to do the opposite of what we think and change the sign on that 3, or change the sign on that negative 3. So that sign, if we change it on that negative 3, is going to become positive 3. So the 3 goes outside. And then the coefficients, we've got 3, 2, degree 1, degree 0. So we've got them all. So our coefficients across the top are negative 4, 11, negative 4, 11, and then positive 8, negative 10. We do not need any 0 placeholders here. So I just copied this down here. And let's see why I got the numbers that I did. This is a process of drop, multiply, add, multiply, add, multiply, add. So the synthetic division process has been developed using adding instead of subtracting, like in long division. But if, like I said, feel free to use either process. So we're first going to, we've got these numbers across the top. So the first thing I'm going to do is drop this negative 4 straight down. And then this 3 is going to be involved. 3 times negative 4 is negative 12. Now we add straight down. So it's drop, drop, multiply, and then add. So this is 11 plus negative 12, which is negative 1. And then it's multiply. So we're going to take this negative 1 and multiply it times this 3, or you could say 3 times negative 1, which is negative 3. So we did our multiplication, and every multiplication needs to be followed by adding. So 8 plus negative 3 is 5. So we just added, we need to multiply. 3 times 5 is 15. And then we add negative 10 plus 15 is 5. And what's in this last spot at the bottom here is the remainder. So I'm going to separate the remainder from the quotient by putting a little vertical bar there. So then if we go backwards, this is the constant. This is the coefficient of our x term. This is the coefficient of our x squared term. So we want to enter what we need to. So you would want to enter negative 12, negative 3, 15 in these boxes, these appropriate boxes. And then negative 4, negative 1, 5, 5 in these boxes. And then down here, what you get right here, this is the quotient. So right here is the quotient. These right. Well, actually, I mean, they're taking into account the variables too. We've got our quotient here with including the variables. So that's the quotient that goes in this box, and this box expands in ALEKS as you need it. So our quotient is negative 4x squared minus x plus, because 5 is positive, plus 5. And our remainder is 5. That's in this where the separation occurs. That's on the other side of that vertical bar. Any questions on this? So in general, the process for filling out a synthetic division table is drop, multiply, add, dot, dot, dot. So I want to look at a couple things while we're here before we go on. This 3 out here is actually an x coordinate. This 3 is actually an x coordinate. This number right here turns out that this remainder is the y coordinate. So the graph of our function goes through the point whose ordered pair is 3, 5. This theory has a lot of useful features to it. Oftentimes, this right here, math people, call it, oh, I've got it out there already, I just didn't notice it. Call this, what number's outside right here, call it C. And in our case, the output we're talking about, we usually call our polynomials P of X. So the output can be written as P of this C. In other words, find the Y coordinate at a particular C value. In this case, our C value is 3. So that in this case, that represents P of 3. In other words, find the Y value of the P function when X is 3. So this is the X coordinate. This P of 3 really just represents the Y coordinate. And that's how you can generate a bunch of ordered pairs where these are the X's and what you get out over here are the Y's, the corresponding Y's. So there's a lot of good theory here, really. We've got a lot going on, and we get a lot for doing a little bit of work. Any questions on this particular question? Let's go on. So let's look at using the remainder theorem to find P of -2. And we just talked about P of a number. For our polynomial P of X equals -2x cubed minus 3x squared minus x plus 7. Now, first of all, I want to tell you, you might be wondering, why on earth are we using the remainder theorem? Because after all, I could just take -2, plug it in for x here, plug it in for x here, plug it in for x here, and do the calculation. That we refer to as function evaluation, and you can do that. And that would give us 13. But if you want to do anything else, like you want to find the quotient and remainder, it's not going to give you that. It's just going to give you that P of -2 is 13. And these other answers, we can't answer them if that's what we do. So what the recommendation is to use synthetic division, because synthetic division is going to give you all 3 answers at this, and that's where we're headed with this. We want to use the remainder theorem. So the remainder theorem states, we're told to use the remainder theorem. It states that if a polynomial P of X is divided by X minus C, that's really what we're doing when we do synthetic division, then the remainder is P of C. Well, in the last example, this remainder here is P of C. So both the remainder is equal to 5, and this P of 3 in this case is equal to 5. So we get a twofer. The remainder is equal to 5, and P of this 3 is also equal to 5. And that's why you see here that the remainder is also the same answer, has this P of -2, just like it was in the previous question. So we need to find the quotient, so we really need to in order to do that, we have to use either long division or synthetic division. So we're going to use synthetic division. So we want to find P of -2. Remember, that is also, we saw that that's also the remainder in the last problem. So what do we want to put out in front of our table here? -2. Now, when it appears like this -2 is not next door to the X, so we use it like we think. We put the -2 out in front here. And that's our C. And it's also our negative. And C in this case is -2. So what do we put across the top? We've got 3, 2, degree 1, and constant. So we want the coefficients, -2, -3. Put -2, -3. The last two coefficients are -1 and 7. -1 and 7. So we're ready to fill out our synthetic division table. So we drop this number. The first thing we do is drop this number straight down. Oops. So this -2 is now below this horizontal line here. And then so it's drop, multiply, add, multiply, add. So we always, when we're multiplying, we always use this number out here. -2 times this -2 is 4. So this -2 times this -2 is 4. And then we add straight down. -3 plus 4 is 1. And now we just added, so we need to multiply. So we're going to involve this in every multiplication. This is -2 times this 1. -2 times 1 is -2. Add straight down. -1 plus -2 is -3. So now we're going to take this, keep our eyes on this. We're going to take -2 times this -3, which is 6, and add straight down and get 13. 7 plus 6. So this is our remainder. And it's also P of -2. It's a twofer. They're both, the remainder and P of -2 are both equal to 13. Because this is the X coordinate corresponding to this Y coordinate. And this stands for Y. It's also the remainder when you're talking about synthetic or long division. Any questions on this? So let's make sure we are stating what we need to state. What did they ask us for? They want the quotient. So the quotient is right here. This right here. I don't know if I can do this. Let me see if I change the color, if I could do this. I'm a very visual learner, so the quotient is right here. I'm going to keep the x's with it. So our quotient is -2x squared plus x minus 3. -2x squared plus x minus 3. -2x squared plus x minus 3. Any questions on this particular topic? Using the remainder theorem. Let's talk about the factor theorem. Let's use the factor theorem to determine whether x minus 3 is a factor of this polynomial. P of x equals x to the 4th minus 3. Now you will notice that the x squared term is missing here. So it goes 4, 3, down to 1 here, and understood 1. So the x squared term is missing. So when we use synthetic division, you will see we'll need to put the 0 placeholder in. So we have so we've got P of x equals x to the 4th minus x cubed plus 4x minus 8. What is the factor theorem state? We haven't formally stated the factor theorem yet. So let's do that. A polynomial P of x has a factor x minus c if and only if P of c. Now, P of c is the remainder. P of c is just the remainder. So this says a polynomial P of x has a factor x minus c if and only if the remainder is 0. That's one interpretation of that. This right here, too much red. Let's go here. And let's click on this. So this right here, let me see if I can get this in here. So I don't want to, this part right here, don't have much room to work with here, but I think I can do this. Not sure why it's not giving that to me. Okay, good. So I'm not sure why that's not working there. Let me click on this. There, okay. Did a little test there. So I think I'll be okay. So this part right here, P of C, I think you can see that P hanging out there a little bit. That's the same as the remainder is 0. That means exactly the same as the remainder is 0. P of C is the remainder. If you look at our last example here, I believe it was the last example. Yes, P of C is right here. P of C, P of -2, and the remainder, there's the same answer. Same answer. So the remainder that means that the remainder is 0. The number 0. So if you get a 0 remainder, you know that you have a factor. If you do not get a 0 remainder, you know that you do not have a factor. So let's take a look. Let's look at our synthetic division table here. So we want to put in our coefficients. Let's take care of this. Well, we can do the coefficients, but let's wait a minute and just go from left to right. So this -3 is being subtracted next door to the x, so we need to change the sign. So it's not -3, it's +3 that goes out here. And then our coefficients. 1, understood 1, understood -1. 1, -1. And then we are missing, there's no squared terms, so we need to put in a 0 placeholder. And then our x, then, so that's 4, 3, 2. This has an understood 1. That's a coefficient of 4 in front. And then our constant is -8. So we want to now do our synthetic division. So this one will be a really good one to ask me if you want me to mark this up so you can understand better, because we've got some free space here to work with. So the first thing we do is drop this number straight down. And then we multiply. And we multiply, this number always participates in multiplication, this 3. We multiply. 3 times 1 is 3. And we add straight down. -1 plus 3 is +2. Then we take our 3 and multiply it by this 2 to get our 6. Add straight down. 0 plus 6 is 6. Then we take our 3 again and multiply it times this 6, get 18, add straight down, and get 22. 4 plus 18. Take the 3, multiply it times 22, get 66. -8 plus 66 happens to be 58. Now, what you notice is we did not get a 0 here. 58 is not equal to 0. Our remainder is 58, which is not 0. So what happens there? If the remainder is not 0, that means that x minus c is not a factor. And our c here is 3. Our C here is 3. So we don't have a factor. So that's why I clicked in this circle. And now they want us to also state this. So this is this 58. This is our X coordinate. This is our Y coordinate when our X coordinate is 3. So this is our, can be represented as P of 3 here, this 58, because this is our X coordinate and this is the Y coordinate when X is 3, and that turns out to be 58. So P of 3 is equal to 58, written right there. So we take the 3, we put it inside here, we put the 58 right there. Any questions on this particular topic? So we have another question here. I don't think we're going to do this one. I think, well, I will talk about a couple of things though. Here, this is the same, this is really the same topic. 2 is being added next door to the X. So when we put this number in our synthetic division table, we want to change the sign on it to -2. So when I worked through this synthetic division table, and let's take a look, the coefficients are -2, -3, -3, and -10. -2, -3, -3, and -10. Fill this out. We drop this straight down. Take this number, -2, multiply it with this -2 to get +4. Add straight down. -3 plus 4 is 4 minus 3, which is 1. Take this number and multiply it times 1. -2 times 1 is -2. Add straight down. -3 plus -2 is -5. Take this -2, multiply it times -5 to get 10. -10 plus 10 is 0. So this time we got the 0. And according to this right up here, and let me be really clear, we got a 0. This is our remainder. This 0 is our remainder. We got a 0 remainder. So we got a 0 remainder. And this up here says that a polynomial P of X has a factor if and only if the remainder is 0, is really what that means. And we got a remainder of 0 in this last problem, this problem we were just looking at. And so that means that we do indeed, our polynomial has a factor. So let's see what we need to fill out. P of -2 is 0. So we put in the -2 and the 0 here. And this right here, this X plus 2 is a factor. So this X plus 2 is a factor. And that, so I clicked in this dot right here. Any questions on this particular topic? And I think I've already alluded to this. So I don't. So what happens is we have this polynomial, this -2x cubed and so forth. So I write it down. We divide by x plus 2 because they tell us right here, they mention this x plus 2. So that's really what we're doing. We're dividing by this x plus 2. And what happened? That equals this factor down here, or this expression down here, -2x squared plus x minus 5, plus this 0 over the divisor of x plus 2. Well, this 0 over x plus 2 is 0, so we can cross this out. And what we can do is we can move this guy to the other side by multiplying both sides by x plus 2. So we can move it to the other side by multiplying this. Yes, multiplying both sides by x plus 2. So if I had an x plus 2 up here, that would cancel with this x plus 2. So x plus 2 is going to end up on this side. And what I just want you to notice here is because we got a remainder of 0, we could cross out this other term in the long division, if you will. And that would leave us with x plus 2 times this factor. That allows us to factor a polynomial. And we've got a cubic here. That's allowing us to begin factoring this cubic. Now we have to question whether we can factor this more, but that's where we're going with this. So getting a remainder of 0 is very handy because it allows us to factor polynomials. So I have another document that I want to look at. We're finished with this one. We've got a couple more topics to look at on this other document here. So let's look at this one. Before we look at this one, I want to mention something. So on Tuesday of next week, we are again going to be using the graphing calculator emulator. We are going to be talking about, on Tuesday, 3rd degree polynomials and 4th degree polynomials. And our goal is going to be to somehow get those down to factor those so that we can factor them into linear factors. Let's say we have a 4th degree. We want to be able to somehow find 2 zeros so that we can write 2 factors as x minus each of those 2, x minus one of those zeros and x minus the other one of those zeros. And then what's left if we have a 4th degree is a quadratic. Well, how are we going to find those other 2 zeros is the question. That's pretty difficult. And I'm going to show you how to do that on your graphing calculators. So I think I encourage you to bring those with you next Tuesday so that you can learn how to do that and we can do it together in class so you can ask questions. We are actually going to use the table of the graphing calculator to find zeros. Part of that is going to involve putting these functions in Y1 of the calculator and then using the 0 feature of the calculator to do that. Remember, zeros are just x-intercepts. So we've seen that before, but we're going to look in the table instead. And that's what's going to be new. So let's take a look at this specific topic. This is what we had to do in the old days to find and factor a polynomial, to find zeros and factor a polynomial. This wasn't a lot of fun because we didn't have graphing calculators in the old days, and when I learned we really didn't have graphing calculators. There weren't even many computers around back in those days. So we had to have all other kinds of theorems and everything. It was a lot of work. But fortunately, I enjoy this particular topic. So it's one of my favorites. So the reason why I am doing this topic at all, to be honest with you, is because even though graphing calculators required for this class, I know that some students, may not have a graphing calculator. So I'm just trying to reach every student that I can, any which way that I can. But it is very useful to have a graphing calculator in this class. And we're going to look at systems of matrices later in a couple weeks, and you'll want a graphing calculator for that class as well. So if you don't have one, you may want to see if you can borrow one. And I say that because there is one assignment near the end of the semester that I'm creating myself in ALEKS, and there are 3 solving systems and matrices topics in ALEKS, but they don't really involve the calculator. So the assignment I am doing myself in ALEKS will not use the ALEKS Pi. It will be one that I specifically create, and you will want to have a graphing calculator for that assignment. And there's really no way around that. So if you can, I would encourage you to borrow a graphing calculator if you don't already have one. So let's take a look at this particular topic using the rational zeros theorem to list all possible rational zeros of the following. Now, the way this works is just looking at this function down here, and we don't have to go through all the notation. This is a polynomial in general written in descending power order. What we want to be concerned with when we're looking for possible rational zeros, in other words, we're looking for possible rational zeros, we're looking for the candidates. No guarantees here. It could be possible that none of them would actually be a zero. Rational numbers are the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and all the negatives of those. They're nice numbers. So it's possible to have a polynomial that doesn't have one of those irrational zeros. So how do we find a list of possible rational zeros? Well, it turns out that we call this leading coefficient Q, and we call this constant term A sub 0, meaning it is degree 0. It's 3 times x to the 0 power. That's why it's got a 0 on it. It's at 0 power. X to the 0 power for any non-zero x is 1, and 1 times 3 is 3. So it's fine to do that. So what we are going to do here is we want to look at, it turns out that the possible numerators above this horizontal bar here are factors of P, which is, this up right here is called P as well. So let me write in the P so we know what we're doing here. It's called A sub 0, but it's also called P. So the numerator are factors of this P. They're factors of 3. The denominators, the possible denominators, are factors of Q, this -5. The polynomial must be written in descending power order to do this. So let's take a look. I wrote the factors of P are factors of this number 3 here. I put in the 3. And the factors of -5 are the factors of Q. So the 3, the factors of P, which is 3, those are the possibilities for what we have in our numerator. And the factors of -5 are the possibilities for what we're going to have in our denominator. So we're going to break it down, numerator and denominator, and then to get our possible rational zeros, we are going to then need to take all possible combinations of a numerator over a denominator. So factors of 3, this 3, and we're looking at nice numbers, counting numbers, they're negatives and 0. So ways that we can get 3 are 1 times 3. They are also -1 and -3 work. So 1 times 3 is 3. Negative 1 times negative 3 is also 3. Two negatives make a positive. So what I did up here is I saw I had a plus 1 here and a minus 1 here. So I wrote this as plus or minus 1 up here. Then there's a comma. And then I noticed we had a positive 3 and a negative 3. So I wrote those as plus or minus 3. Those, we've got the plus 3 and a minus 3, and we can write them together as plus or minus 3 here. So those are our possible numerators, what's above the fraction bar here. Down here, we can write negative 5 as either negative 1 times 5, that would give us negative 5, or 1 times negative 5, that also gives us negative 5. So we have negative 1 and 1. So again, we write plus or minus 1, comma. We have 5 and negative 5. That's 5 times negative 5. That's plus 5 and negative 5, which we can write as plus or minus 5. And we need to list our possible rational zeros. We need to find all combinations of one of these 4 that we have. We have 4, 2 from here and 2 from here. We have 4 possibilities in the numerator and 4 possibilities in the denominator. So that's going to give us a possibility of 8 different rational zeros. So let's find those combinations. So I'm first going to look at these red, let's call them lines, these red lines here. I'm going to take this 1 here and do 1 over this and then 1 over that. I should mention that you don't have to do this analysis like this. Just find each factor, different factor, and put plus or minus in front of it. Same down here. Find each different factor and put plus or minus in front instead of doing all of this. I did want to show you, though, that we really need the plus or minus. So we will do 1 over 1 first, which is 1 divided by 1 is 1 with the plus or minus sign out front. You're always going to have to put those plus or minuses in, though, like I've got them. Then we're going to do this 3 over 1. 3 over 1 is 3. 3 divided by 1, rather. Let's be clear. It's 1 divided by 1, which is 1. 3 divided by 1, which is 3, with a plus or minus out in front. Now, we are done looking at doing these numbers over 1. Let's now look at these same numbers over 5. So let's look at the purple lines. So we want 1 over 5, which is 1/5, with a plus or minus out in front. We now want 3 over 5 with a plus or minus out in front right here. So we get 2 possibilities from each of these 2, 4, 6, 8 total possibilities. So Alex wanted us to list them not with the plus or minuses in them, but to actually write out 8 different ones. So we get 1, negative 1, 3, negative 3, 1/5, negative 1/5. They came from this one. And then 3, negative, 3/5, and then negative 3/5 down here. And they wanted them all separated by commas. Now, even that is a lot that you would have to check by hand if you didn't have a graphing calculator. So you want to make sure, I think, that you have a graphing calculator. I don't think Alex has calculators robust enough to use a table to find the zeros. So any questions on this particular topic? All we were asked to do is to list all possible rational zeros, and there's no guarantee that any of these are actual zeros. So here's the written work topic, this written work required topic that's going to be one of the 7 written work required topics on test 3. So let's take a look at this now. And this is really what it's all about. Looking at polynomial theory, we look at it so that we can factor higher degree polynomials. We've talked about linear functions. We've talked about quadratic functions. And if you have a quadratic expression set equal to 0, you can always use the quadratic formula. But what happens with a cubic? Here we have a cubic polynomial. The highest power is a 3. What happens in a cubic situation or a quartic situation? And there, our goal is to get it to do enough work so that all that are left are linear and quadratic factors. And then we can set the quadratic factors equal to 0, and worst case scenario, use the quadratic formula. And if we set a linear factor equal to 0, it's easy to solve. So for the polynomial below, -3 is a 0. Luckily, they gave us a 0, right? So let's start with that 0. And because they gave us a 0, this is the x right here. This is -3 is the x, and you can see that down here. The output needs to be 0. The y needs to be 0. This guy over here, the y needs to be 0. And I say needs to be 0 because this -3 we are told is 0. So we need to get a 0 out here, the number 0 out here, or we've done something wrong. And remember, a 0, Z-E-R-O, is an x coordinate that makes the y coordinate equal to the number 0. So the -3 is the word 0, whereas the y needs to be the number 0. This one's the word 0. This one has to be the number 0. So let's look at our polynomial. It's a cubic, 3, 2, 1. Constant term, we can write down all the coefficients. We don't need to, we won't include any 0 placeholders. We don't need them. So this is coefficient. First of all, this -3 is not next door to an x, so we copy it down as is. Then our coefficients, 1, 5, 5, -3. And we use synthetic division. I already showed you this. If you're a long division fan, if you know how to use it, that's fine. You can use long division, but I showed you where you could click on using synthetic division. So every time look for, I would encourage you to learn synthetic division if you don't already know long division. It's much quicker and I feel more accurate, and you don't have to write in all those x's. So let's fill out this synthetic division table. And this is how we do it. We drop that 1 straight down. We take this number and always use it in multiplication, -3 times 2. Wait, -3, I got ahead of myself, -3 times 1. So we have to use it with this one, -3 times 1, that's -3. Add straight down, 5 plus -3 is 2. -3 times this 2 is -6. Add straight down, 5 plus -6 is -1. -3 times this -1, +3. -3 plus 3 is 0. We were told that this is a 0, so we need to get the number 0 here. Otherwise, we've made a calculation error, or we forgot a 0 placeholder. So this, now what we have here, we've got our 0. We got a number 0 here. So this gives us the ability to factor. We know we have a 0. That -3 is a 0 because we got the number 0 here. So we can write down a factor of our polynomial. It would be x, by the factor theorem, it's x minus this 0. So it's x minus -3. And we're using g of x for our polynomial. So our first factor is x minus a -3 by the factor theorem. It's x minus our 0 of -3. Our other factor we get from this quadratic function over here. It's actually is a quadratic function, but it's really, let's more precisely call it a quadratic expression. So separate off the remainder, which we got 0, from the rest here is a good thing to do. We started with a cube. We started with the 3, but we've already found one of the factors. We have, this 3 means we have 3 zeros and 3 factors. We've already found one of the factors. We only have 2 of them left. So we are talking about a degree 2 here. Or you could go backwards and say this is the constant term, this is the x term, and this is the x squared term. You can go backwards from this side of that vertical bar. So what do we get? We get x squared plus 2x minus 1 has our other factor. X squared plus 2x minus 1. And we're setting all of this equals 0. Why are we setting all of this equal to 0? Because we are looking for the axis. We're looking for our zeros. We found only 1 0 so far. And when we are looking for zeros, we are looking for the x coordinate that makes y 0. So that's why I took out this y here and put in 0. So we clean this one up, x minus a negative 3. I think we already did that, but that's x plus 3. How are we going to deal with this? We set this equal to 0. X squared plus 2x minus 1 equals 0. That's what we need. We set it equal to 0 down here. That's what we need to use the quadratic formula. We need a quadratic expression set equal to 0. We're required to have that to use the quadratic formula, or it won't work. It won't likely work. So what I want you to notice here is there are 2 sets of parentheses here. There's the orange set and the purple set in each one of these. And we'll talk about these more after we look at the next page. The outer set, the orange set, is for our factor that indicates our factor. This purple set is our actual 0. That's our actual 0. So that's important to realize. This purple set here is in purple, that's our 0. That's our 0. That's denoting our, what's inside is our 0 that we're going to find. The orange set, on the other hand, the whole thing, the orange set, so I'm going to do it in orange, is these parentheses are for the factors. So I want to make sure you all understand that, because I'd hate for you on the test to do this. This is a written work required topic, and I'd hate for you on the test to get the whole problem right and then not have and miss it because you didn't have the parentheses correct. So I guess what I should really emphasize to you, and hopefully this would emphasize it to you. Let me see, where are my markup tools? Maybe I need to, I need to get it again. Okay. I want to make sure you understand, I forgot to put the orange around this right here. Always trying to improve what I do. Okay, so the orange parentheses are around the factors. X plus 3 is a factor. Got it by taking X minus a minus 3. That's a factor. This orange set is around another factor. This orange set is around the third factor. So the first factor, the second factor, the third factor, we put orange parentheses around each one of those factors. Now, the purple parentheses are around the zeros. We've got a 0 here, and we also have a 0 here. -1 plus square root of 2 is a 0, as is -1 minus square root of 2. So let's take this other factor, this quadratic factor, set it equal to 0. So I wrote it down here, and let's solve for x. We can use the quadratic formula to do so because we have a quadratic equation where the highest power is a 2. And it has to have an x squared term in it to use a quadratic formula. So let's go down here. I just copied that over. And we need to identify our A, B, and C. Our A is the coefficient of x squared, which is 1. Our B here is the coefficient of x, which is 2. And our C is the constant term, which is -1. So this, I just stated the quadratic formula here, so we can all refer to it. So we want to copy down the x equals negative b is 2. So I took out the b and put in 2. Plus or minus square root b is 2. Put that at 2 in parentheses and squared it because we have b squared minus 4 is from the formula, minus 4 times A is 1, times C, which is -1, put it in parentheses, all over 2 times A. So the 2 is part of the formula, A is 1. And so let's just work with the square root now. 2 squared is 4. And then we have negative times a negative is a positive. 4 times 1 times 1 is 4. So we get plus 4 here. 4 plus 4 is 8. We have the square root. We need to put the square root on. 8, if we break it down, is 4 times 2. So it's square root of 4 times square root of 2. Square root of 4 is 2. And then we have square root of 2 left. So this is as simple as we can get it. So at this time, we have -2 plus or minus our 2 root 2 here, 2 root 2, all over 2 times 1, which is 2. So in math, we spend a lot of time talking about factors. Then that's we can cancel factors. We cannot cancel terms. I can't cancel this 2 with this 2. I can't cancel this 2 with this 2. I can't cancel this 2 with this 2. So you want to be very careful, and I recommend that you factor. I find students who factor are more likely to get the answer correct. So if you notice, terms are added and subtraction's adding a negative. So you can consider subtraction as a term. This term has a 2 in it, does this. So let's factor a 2 out in front. So I put a 2 out in front. That 2 went out front, but there's still this negative left. That negative sign represents -1. So I have -1 in here. Plus or minus, this 2 went out front, which left is the square root of 2. And you can go backwards. Distribute this 2 through. 2 times -1, -2. 2 times square root of 2 is 2 square root of 2. You've got the plus or minus here. And then, of course, divided by 2. So if you're going to cancel, my recommendation is to you to understand why you're canceling. And before test 3 in the comprehensive final, I would recommend, if you don't understand if you can cancel, that's anything, please ask me. It's important to cancel because you know why you're canceling. So like this 2 divided by 2, this 2 divided by 2 is 1. And 1 times, there's times understood here, 1 times what's left is what's left. And that's why we can cancel those 2's. So we are left with these two numbers, and those are our 2 zeros. We first pick the -1 plus square root of 2, -1 plus square root of 2. You see that inside the purple parentheses. And then our other number is -1 minus square root of 2. -1 minus square root of 2 goes right inside here, and that's why you want to make sure you're putting parentheses around your zeros. So the reason why we write them this way is because x minus a 0 is a factor. X minus a 0 is a factor. Any questions? So we are done for today. Anybody have any questions or comments? So we've run a minute over. I apologize for that. Let me quickly, though, make sure I get another screenshot or 2 of the attendance so I can make sure everybody gets credit for attendance, especially those at the end of the, who have last names at near the end of the alphabet. So take care, stay safe, and I will see you next Tuesday. Have a great weekend, and if you want to stick around and chat with me, I will stick around to chat with you if you have any questions or comments. Take care. Bye for now. Let me turn off the recording.